First of all, welcome to the fourth Jens lecture series. And today is actually it's my honor to introduce Professor Peter, who will be our speaker today. And I'd like to have a little bit of a brief introduction of this Jens lecture series. Thanks to generous donation from Dr. Jens' family, and this lecture series is actually jointly organized by New Asia College and School of Life Sciences. And I'm not sure if you know, Yong is actually the first founding head of Department of Biology. Okay, I just checked with for those know that actually he retired. Okay, before I even be a graduate student here, so it's a very, very long history. So it's a founding head. Okay, he's actually a taxonomist and is an expert on that. And I'm going to introduce Professor Peter Ng. And Professor Ng is the professor of biology and the founding head of the Lee Kong Chian Natural History Museum at the National University of Singapore. He's an internationally renowned taxonomist, and his main research interests are on the diversity and biology of crabs and fishes. And he shared, in his first public talk on he liked catching crabs and fishes. And in his career, he's conducted many expeditions over 25 countries and hundreds of locations all over Asia, and has been involved in discovery of more than 500 new species of fish and crustaceans. Professor Ng has authored over 950 technical papers and articles, as well as over 25 books, and has been served as a scientific expert for a number of national as well as international agencies. In fact, he also has vast experience in securing funds from private sector. For example, I'll give you one example. In 2009, he's actually single-handedly secured 60 million Singaporean dollar to build the new Natural History Museum in Singapore, and have developed an endowment plan that will be financially sustainable to support the museum for a long term. With his scientific achievement and his experience, I think he's probably the best person to share with us his insight into today's talk on games scientists play. Without further ado, let's welcome Professor.
Thank you, KB. You can hear me behind, I assume? The mic is working, okay. Well, firstly, thank you for inviting me down to Chinese University of Hong Kong. This is my third talk, and I'm relieved it's the last one. And this is the one in which probably the audience is also the most targeted, because I'm speaking to most of you are biologists or biologists to be. Well, nowadays, the new way is life scientists. Okay? Yeah, but biologists. And I thank, of course, KB for so nicely hosting me. Professor Chu, who persuaded me to come to Hong Kong to give this series of talks. And it's nice to come back to Hong Kong once in a while, right? Because I have many old friends here, of course. And it's nice to see old friends. It's not very old ones, okay? And then the thing about Hong Kong, of course, and Singapore, right? Our two countries have very similar ways of thinking, because the way that our countries have come across is because, well, primarily we are colonial bastions of the past, okay? You until 1997, Singapore until 1960. And the way we handle science, the way we teach, the way we do education is very much a Western model, not so much the Eastern model. So in many ways, Singapore and Hong Kong share many similarities. Right? And when I start looking at what kind of science our universities are doing, the similarities get even greater. The way we look at science, how we conduct science, how we measure science becomes even more similar. So today I'm going to give you a short talk, right? It's a talk not based so much on how you become a great scientist, right? It's more about how you should look at science and what you should try to do for the future. Most of you are young postgraduates, you're doing a degree right now, finishing the degree, and of course you want to pursue a scientific career. And you may ask yourself, what would you like to be in years ahead, right? The world is changing very fast. Some things doesn't seem to change, including this, okay? So, I'm going to tell you some things which probably most administrators, most of the professors won't tell you because they are usually very polite. So today I will be not so polite, okay? And I use games because science is supposed to be something very noble, something very important for society, and therefore we take it very seriously. Unfortunately, like everything else human beings do, we sometimes have a habit of changing it to suit our needs. Every university, every young professor, every older professor, every graduate student to be, right? You look at a university, and inevitably, we start looking at all these things. We all use the word KPI here in Taiwan as well. In Hong Kong as well,
yes.
Right? Key performance indicators, right? Okay, I mean, how do I know if you're doing a good job? You have benchmarking. You compare your department or your school, you compare your university to other universities around the world to show how good you are or not good enough. We like to benchmark, right? Among the universities in Asia, my university, your university, Hong Kong U, Nanyang, they're all competing to be number one. Because to be number one in Asia is very important. I don't think so, but my bosses think so. If you are in life sciences, you will know what this is. If you publish in journals, you publish in top papers in places, they ask you whether it's on a citation index, whether it is captured by the indices. If you publish in a journal that nobody ever heard of, not recorded in any index, then your paper is considered not important. Then you look at impact factors, whether you publish an impact factor 0.1 or 30.0. The higher the number, the better for your career. I don't know about the graduate students here in Hong Kong, right? Whether you are obliged to have many SCI papers published before you graduate. They need at least one. Okay? So impact factor at least 10, right? Before they can graduate.
We have some
Okay. Yeah. So really impact factors are important. So this comes into the field of biometrics, which basically is how you measure the impact of your science, the impact of your paper. And this is actually the essence of what we can talk about today. Right? Now, I am a taxonomist, as Prof. KB has said a few minutes ago. A taxonomist is a person who finds out what kinds of animals and plants there are outside. I think it's a very important job. But the problem, of course, with taxonomy is that it is not one of those sciences that gets you very high impact papers. Yet, in my university, impact factors are just as important as your university. What do we want our students to be? Our own graduate students in Singapore. We want them to have 1 or 2 SCI papers, right? Generally good ones in their field. We don't fix it. We have discussed it before. One of my heads last time said, minimum impact factor 10 and above before you can graduate. They said, all right, half the department only to graduate. Not possible. And let's talk about that. All right, world class, huh? Every year, all the QS, the Times, all they do ranking exercise, okay? Chinese University of Hong Kong, what's your position last year? Somewhere not there, I think. In Asia, I think you're probably top 10, top 15.
Probably lower than US.
Huh?
Probably lower than US.
In Hong Kong, you guys are among the better ones. In Asia, I'm pretty sure you're in the top 10 or top 20. So you're up there, all right? And I'm sure your Vice Chancellor, still Vice Chancellor right here? Yeah. Okay? Yeah. In Singapore, we went to American model. Our Vice Chancellor are called presidents now. Okay? So Vice Chancellor and presidents, every year they look at these rankings and they get very excited. Right? In my university, every year they must be number 1. If they slip a bit, they panic. And they want to be number 1 in all the different rankings. Not easy. Okay? And because of that, all the researchers, all the postgrads, all are under pressure to make the university famous and great, right? So you guys want to be number one. I'm sure the Vice Chancellor wants you to be number one, right? And he will try to push you to be number one, okay? Well, we are number one. Very stressful. So we all day look at rankings. And the problem with Asia is that all of us are obsessed with ranking to be number one. What does number one mean? What does number one whole university mean? You have medical, you have law, you have life sciences, you have all sorts of disciplines. You average all of that out, you're number one. It doesn't mean that everything you do is number one. Averaged out, you're number one. And if you're a life science student, how does your school stand in Asia? Of course, for each discipline, they also have rankings, right? And it is a very difficult business to measure if you're in one area called biology. My point is, and we try to tell this to our students and my colleagues, my younger staff especially, benchmarking is important. Why? We should compare to know roughly where you are, how you can improve. Because you don't want to tell them, well, I'm good. Don't ask me why I'm good, I'm just good. You have to compare yourself with somebody. But when you compare with somebody which is much better, you try to be like them. Doesn't mean you can be like them, right? Benchmarking is good to let yourself know roughly which direction you want to go. But to go in that direction 100% is also dangerous. This is Oxford, right? I think last year, I think Oxford and Cambridge did very, very well, right? But of course, those universities are also very, very old. Okay, one of the very important criteria, and all young researchers have to worry about, is publications. I'm sure your lecturers, your professors, your supervisors are pressing you, must publish more, right? Must publish in good journals. Must publish with high impact factor, right, Ming? Otherwise, they won't give you a tenure.
Just ask my boss. You better ask yourself.
That means the answer is yes. So, these things, we are very conscious, okay? Now, so this is the part I'm going to tell you a story, okay? But before I do that, you must understand how biometric indices work, okay? Do you know how an impact factor is calculated? I mean, you hear a professor say impact factor 1, impact factor 10. Do you know how it's calculated for one journal? That's very simple, okay? If a journal publishes 10 papers a year, okay, and all 10 are cited, used by other people in that same year, your impact factor is 10. 10 divided by, impact factor is about 1. 10 to 10, 1, okay? So that's an impact factor of 1. If your 10 papers have been cited 100 times, your impact factor is 10. As simple as that. Okay, it works over a period of time. How many times it's cited, divided up, and you get an impact factor. Averaged out over many years, you know roughly where a journal stands. The impact factor is dependent on how many people are doing that science. There are 30 or 40 people in the world working on crabs. There are about 50,000 people working on cancers, just of the stomach. So, which discipline should you be in if you want high impact factors? Stomach cancer. Of course, you may not be interested in stomach cancers like me, then you work on crabs, right? Then your impact factor in journals, the journals you choose cannot be so high. Citations, journals you choose. Do journals try to improve their impact factor because the journals are owned by big companies? Of course they do. They know we want to have high impact journals. So they try to make their journal impact factor higher. How to do that? Well, the editors sometimes ask, choose papers. I get a paper from KB, I read it. This one, only 3 scientists in the world interested. Oh, he said pigs can fly. Publish. Sure, a lot of people will cite it, even if they don't agree. Sorry, what did I just say? Even if they don't agree. If anybody says he's mad, they write 100 papers to say he's mad. It's still 100 citations. Now you begin to see that it's not always fair. Journals choose papers. They should not be choosing. They should be choosing the paper based on the quality of the paper, not based on potential impact. but journals choose it. How do you make sure your paper is cited? Well, we would like to think that when you cite the paper when you're writing a paper, you cite somebody, it's because that paper is relevant, right? Because I write paper on crabs. KB has written a paper on crabs. What he's talking about helps my story, right? I cite him. No, not always. What do I mean not always? Some papers, like review papers, I write a paper, crabs of the world. Everybody will cite me. Why? Because I talk about everything. So my citation goes up. Is that artificial? Partly. Reviews get a lot of citations. Some of the best impact factors, best citation I've got are big reviews I've done. Is it fair? Not very. Some journals, not just some, many journals have another problem. To make this even more biased, what we call manipulation. They want you to cite the papers published in their own journal. They write to you, right? Dear Professor Chu, you know, I read your paper to be published in my journal, very good. I noticed that you did not cite papers A, B, C, D, which was published in my journal last year. Would you consider citing them, please, before I accept your paper? What would Professor Chu say? Hola, musuh kau na. Because if he says no, he worries. Maybe people will be rejected. Or worse, still stand up for another review. What's one more, two more? Does it help the journal? Of course. Is it manipulation? Yes. Is it illegal? Do journals do that? I know they do that. Okay, I will talk to editors. I tell them it's not fair. I say, what's fair? It's a competition. I'm not asking Professor Chu to cite a paper totally irrelevant. It's relevant still. And sometimes, as some of the scientists here know, you can cite A, B, or C. Or all three, right? It's up to you, depending on what you feel is right. All this, authors can manipulate as well. Very often, authors like to cite your own self because you think you are better. That's normal. I like to cite papers with my friends because I like my friends more than I like my enemies. Is that normal? Yes, it's human nature. So I add all this manipulation, interpretation, all this in, means you begin to realize that this impact factor thing is not that objective. Right? But yet, most universities use a lot of it. Even in my university, we always argue with my chiefs. Oh, impact factor 10, good. Impact factor 3, no good. Okay? And another thing about impact factors you must know, you may not know. There's something called a half-life. They look at it only from about 5 years. Now, in biology, life sciences, one of the most important papers is Darwin's book on evolution, right? Darwin's book, impact factor 0 分, because it's too old. In the system of biometrics, 无聊, obsolete. How can Darwin's theory be obsolete? I can cite Darwin 100 times, you will not be captured because it's way too old. So if you publish something today, and somebody finds it's very important, 8 years later, too bad, you're too late. Your impact factor, your citation, not counted. Now, all these things, when you add it in, tells you when you use bibliometric characters like this to measure citations, whether it's citations, whether it's impact factor, you have to use it very carefully. Never have I said all these things are useless, but they are a problem. And many administrators, when they use it, they don't realize what it actually means, right? Some of my colleagues, scientists also are guilty. Why? Because their field is very important. I have a lot of medical colleagues, right? This morning we talked about medical science. Medical impact factors tend to be very high. Why? Because there are a lot of doctors. Medical research is important, okay? And therefore, their citations are high. And they therefore think they're very important. Science doesn't always work that way. Now, this is the gold standard, right? All of you should try to publish a paper in Nature or Science or the Proceedings of the National Academy of Science, right? Have you told your students this? I'm sure you have. No.
Hopefully they know.
They know.
I'm surprised they didn't know.
You know, back about, what year is this now? Oh, in the early 2000s, okay, my dean. In those days, NUS was not #1 in Asia. Our deans decided that they will press all the science people in the Faculty of Science to publish more in SCI, more in high impact, all right? And they started to push everybody to publish in higher and higher impact. So of course, some people publish in Nature and Science quite often, and they will always say these are our top scientists because they got 2 Nature papers, 3 Nature papers, 2 Science papers, right? And every year these are the people that, you know, the big bosses say, all the others, right? Now, as I said, I'm a taxonomist, okay? Now, when I describe crabs and fish, where do I publish it? I publish it in a journal that my colleagues will see. Journals on crabs, on fish, on biodiversity, on conservation, because this is where I want people to read. The people in that field will read those journals. Now, of course, I'm just saying that. If I find new crabs, can I publish it in Nature? They laugh at you, who cares, right? The kind of animal that always goes to Nature and Science are dinosaurs and monkeys. You find a new monkey, you can probably put it in Nature or Science, right? You find a new dinosaur with 2 heads, you can probably publish it down there, right? But generally, you don't publish it in Nature or Science. So, in the early 2000s, when we had this discussion in my university, people like me, and like many of you, working on biodiversity, working on environment, we have a problem. Because the bosses kept calling us moron, right? The word they use on us is an English word, I don't know whether you know, they call us riff-raff. Basically, useless people. Highest impact, what? 5, 10, medical, 20, 30. Every year they got 1, 2 Nature Science papers, right? So in the early 2000s, as this debate was taking place in the Faculty of Science, my own department, biology, right? Myself and 1 or 2 of my colleagues, because we think we are good scientists, not just those guys doing Nature or Science, right? My head of department was telling me, you don't bother, you all can never publish in this sort of journals one, because what you're doing is play, not important one. So, now I have a very bad habit, as I just said in the last lecture, right? When people tell me I'm useless, I get very, very angry. When people tell me it can't be done, I get very, very angry, right? So I called a few of my colleagues. I want to make my dean and my head lose face. He tells everybody you're useless, okay? So I want to make him eat his words. Nature and Science is very important because a lot of them want to use it as a criteria for your promotion or entry into university. Now I'm going to tell you about what we did, okay? Now, because all of us doing biodiversity don't have papers in Nature or Science, every time I complain to the boss, tell the boss it's unfair, tell the dean is wrong, tell the head is wrong, they'll say, go away, okay? You all can't publish in Nature or Science, right? The reason you complain is because you can't do it. You say Nature and Science is not the best science because you can't publish there. That's why, sour grapes. No, actually it's true, right? Human beings are like that, okay? So, the reason you say it's no good is because you can't do it there. I'm sure you heard all the stories before. So, you want to prove him wrong. The expression I use is, I think Hong Kong is the same problem as Singapore, right? I had some students, we met some young people, and we asked them, so what do you do in Korea? I'm a marriage counselor. First question I asked them, are you married? No. And you'll be surprised in Hong Kong, a lot of marriage counselors are not married. Then I asked them, you counsel people are married, you're not married. How can you do that? I said, oh, because I got 1 PhD, 2 MBAs. They got the degree. Then I don't trust them. Why? Because marriage is something you have to live through, right? If you tell me you divorced 2 times, married 3 times, maybe I listen to you. But not really. At least you got experience, right? So, here's the story of an unmarried marriage counselor. If I want to argue with my boss about Nature or Science, I need to prove to him that we can do it. So I talk to my colleagues at biodiversity. Most of them say, no point, I work on ecology, I work on biodiversity. Nature or Science is, not something I'm interested in, okay? Can't be done, not interested. So we try to get them to help. So, First thing is, we want to prove the boss wrong. We play his game. So I started looking at the things I do. I started looking at things my colleagues do. Now, in about 2003 or 2004, I had an American visitor working with me in Singapore, very cool, okay? He was playing with snakes. Yeah, I don't work on snakes. But the reason I was involved because the stupid snakes eat my crabs. So I was involved, okay? Because I was helping him catch the crabs, catch the snakes, and then we were doing some bad things to the crabs. Now, this is, all the scales here are approximately correct. Now, you all know snakes, huh? How do snakes eat? They catch their food, they strangle them around, and they swallow them whole. Right? Have you heard of a snake that breaks the food into small pieces and swallow like us? No. So, my friend working on snakes had a problem. He was working on a snake that lives in mangroves, mangroves. And when he opened his gut, he found crabs inside. So he took the crabs out, showed it to me, and said, this is this crab. So when you join all the crabs together, I said, the crab is bigger than what the snake can swallow. Because the mouth can only grow so big, and the crab was bigger than that. This is about the right proportions. So we kept the cat, kept it in the fish tank, used infrared, observe it at night. Stupid snake, very smart. Catch the crab, use the coils, hold the crab down so the claws cannot bite it. Then bite the crab off piece by piece. Pull out one leg at a time. Right? Then swallow every piece one by one. He told me, we sat down and said, but snakes don't do this. Yeah, snakes don't do this. First time, very good. Okay? He said, you publish it in a snake journal. I said, no, I don't publish it in a crab journal. Then suddenly two of us said, you know, maybe nature might like it. I said, yeah, maybe, yeah, but you think nature be interested in snakes? Well, interesting because up to then, nobody's ever found a snake that breaks its foot into smaller pieces. And we got some cool video infrared. Right? So we took it together, sent it to Nature. Now Nature is a very nice journal. You know why? Because if they don't like the paper, they can reject it very fast. One of my colleagues, the fastest rejection is 4 hours. We send it in the evening, and by the day and night, they say, yeah, so and so. Go away. Very fast. If you didn't hear from Nature after one day, you feel very good. 1 week later, came back. Okay, we will publish a paper if we shorten it. We were so happy. So this was the paper we wrote in 2003, 2004, okay? The title doesn't sound sexy, but basically means this snake can swallow a larger food than what the mouth allows because it breaks. And there's a nice link, you can see the video even. What did Nature want? The science must be cool. The science must appeal to a large audience. Anybody who even doesn't know snakes or crabs will read it, very interesting. It must be newsy. To add value, have a good video. People love videos. Okay. So, this first paper came out, he was happy, I was happy. Then I realized, actually it's not that difficult, no? Then here's the best part. A few weeks later, the head of the department, heads, every few weeks, you meet all the staff around. Tell them how to doing, right? And then my head said, there's something strange. There's a paper by the biodiversity people, and it's in Nature, right? I don't know how they did it. Okay. So, first cut, can it be done? Yes. For me and my colleague working on snakes, it's not our normal nature to put it in a high-impact journal like Nature or Science, because we always think that's for the big things. If you think differently, you'll be surprised what can be done. Now, after making the head look bad first time, I asked my colleagues, let's do it more. Right? Hey, one time, maybe just pure luck. All right. So I got another colleague involved doing conservation biology. Now, in Singapore, around early 1990s, like in Hong Kong, we got all the NGOs and scientists together to compile what we call a Red Book. We have something like this in Hong Kong also. A list of animals and plants which are threatened by extinction, endangered, or even extinct. All right? The nature community had put put this book together. What does this book do? It takes everything from Singapore over the last 200 years, we compile it. This extinct, this very few, this one should die. And it's a document for conservation biologists, right? To help people, do impact assessment and so on. You have the same thing, similar thing in Hong Kong as well. So I had this idea, I talked to my conservation biologist, look, Singapore is a small island, surrounded by sea. All the things in Singapore, we should know what is there. The birds, the plants, the mammals, the fish. The English, which were our colonial masters, are crazy people. Why? Because they're supposed to be taking care of the country, but most of the time they were out there doing muliao things like catching birds, catching fish. Your guys are the same. In the 200 years that the English occupied Singapore, they actually compiled a lot of information. Because every time they saw a bird, they recorded it. Every time they caught a fish, they recorded it. So all the big plants, big animals, major plants, major animals, the actual English recorded it. And we followed up by adding more. So I said, we should have a pretty good understanding of what are the big animals and plants in Singapore. Let's go out and test a conservation theory. Now, one of the nicest conservation theories proposed by two very famous men, okay, E.O. Wilson and MacArthur, is what we call the 90%, 50% rule. That means when 90% of a forest has been cut off and destroyed, half the biodiversity will disappear. It's not 90% disappear, 90% biodiversity. It's 90 to 50. So when most of the jungle has been cut away, half the species will disappear. Right? It's a theory proposed by these two men, both very famous biologists, right? And they had this theory based on what they did in South America. It's a theory that has never been proven, right? And I said, why don't we go and test this theory? I said, how do you test? I said, use Singapore. Singapore is small, 600 square kilometers, right? We have good data. And 95% of Singapore's forest has been cut away. Let's test out whether 50% is true or not. Oh, well, good. Let's do some modeling. So we started taking a red book, put our data together. We caught all the people, locked them in the room for 1 week, and started. Can it be done? Yes, it can be done. We found out about 45% of the birds, mammals, and fish had disappeared. About half the plants have disappeared. Basically, is using Singapore as an example, and this very nice, sexy title, okay? We managed to prove Wilson and MacArthur's theory, more or less proof, okay, substantiated, that 90-50 is a good hypothesis. We said in the Nature. After one time to try again, all right? They accepted it. And then we also made sure we chose a very sexy title. Title must capture your attention. Don't like, Singapore has high extinction rate. That's no good. Catastrophic is good. Okay? I chose that title. Okay? Put the data in. When it came out, it was a big paper. Everybody was excited. The West, the East, everybody, and suddenly, the university, my faculty at least, the perspective of us, the Wuliao people, changed. Oh, you mean they actually will publish this sort of things in Nature and Science? Yeah, always. Just they never thought we could do it. Actually, this paper, when it came out, almost got us into trouble. Because the first complaint we got was from my ambassador in the United Nations. He said, who the hell are these scientists who put the country Singapore name and the word catastrophic together in the same word? This is bad for Singapore. Who are these? So the provost called me and said, Peter, complaining. Said, don't worry, turn to page 3, paragraph 4. I said, why? Paragraph 4 says, most of the destruction were done by the English. Before Singapore became independent. That was my main contribution, right? Okay, yeah, yes. Richard Collett was with me at the time. First thing, Richard, you blame the English for everything, which is true. Okay? Now, the idea is to take information that people have worked on to convert it to ideas that can be published in good journals. The big journals like Nature and Science, what they are taking are stories that capture a bigger attention. A lot of the time, we don't send to Nature and Science because we think our story is too small, not big enough, not interesting enough. I encourage you to try, because you have nothing to lose, right? It is surprising what Nature will accept or not accept. It's actually very interesting, right? You should do it for Hong Kong. I think the numbers will be just as bad. Okay? Who does this sort of things here? I don't know. Joe, do this for, yeah. Then your CEO will call, your chief executive will call you up. You know, when I first started this, it was mainly to prove my head wrong and to make my head swallow his words. The team was happy, the head was happy, because the university was happy. The problem with all these things is that once you know it's like disease, Chinese have it, yao yan, right? Suddenly, let's do more. Okay, so my colleagues and I all started doing more. Year by year, the number of Nature and Science papers we published increased. So on average, after 2003, on average, the biodiversity people will have about 2 or 3 papers in Nature almost every year, or Science, or PNAS, right? And of course, we felt good in those first few years. Now this one is good fun. This is my good friend from Taiwan. You know where this place is? You know, Ming, Turtle Island, northeastern Taiwan, okay? This bubbling here is real. This bubbling here is hydrothermal vent. There are gases, there's volcanic gases coming up, right? Down here, my good friend from Taiwan, Zheng Mingxiu, went diving. Lovely place. I will never dive here. Stupid, dive here, right? Because the bubbling is dangerous, and if you are wrong place, you can cook your life. He found lots of crabs. The crabs had a very strange behavior. Most of the time, they're hiding in the cooler places under the rocks, and they only come out to feed once or twice a day. Sometimes you see them all swarming out one time a day, eating rapidly, and then all going back to hide. He told me, he showed me the video, we discussed. I said, why does a crab do this? Talk and talk and talk. I said, you know, we're talking too much. There's something funny happening here. Why are the crabs coming out once or twice a day only? What is triggering them to come out? Okay? What are they eating? Oh, they're eating giant bacteria that can be found in sulfur. Couldn't find them in the gut. So we were very curious. So I told him, he said, no, this can be a paper. And I said, yes, it can be a paper, but I don't know what's the story. So he came down to Singapore, we sat down in my lab for 1 week. I said, don't get distracted, just focus. Look at all the evidence, just like a court. Just look at the evidence, show me all the videos, took all the data, put a big chart, start making sense. Right, the crabs swarm at one time a day. Then finally, the story came out. So what we think is a good story, right? I asked him, so when do you see the crabs coming out? Oh, I usually see them because it's easier to swim. I said, what do you mean easier to swim? Oh, you know when the tides are changing? It's called the interperiod. High tide, low tide, and then it changes around. When it changes, the currents are very strong. He said, oh, I usually see them when the tides stop changing. Exactly at that time. So, oh, that means the water's not moving. Yeah, water's not moving. That's when they all come out. He said, ah. He said, why? The crabs don't care about the currents. Then one day we're just drinking coffee. You know, sometimes when I stand there, dead fish float in front of me. I mean, dead fish float in front of you. Oh no, this stupid fish, you swim past, they get killed by the, you know, the volcanic things. And then when they get killed, they float down. So when they float down, yeah, you know, when I'm swimming watching the crabs, a lot of things float down. He said, what do you mean a lot of things float down? Yeah, because you know the gas is coming up, right? They're killing all the plankton and the fish. It's hot. That was the magic moment. What is happening is, when the tides are not moving, the hot water coming up is killing the animals, and the animals are falling down. And the crabs know it. They are coming out to eat the dead bodies. And when the currents change again, what happens? All these dead animals get washed away right around. So the crabs know there's no food, they go back to hide. Oh, so happy. I said, Mincho, let's write a nature paper. No lah, Peter, it's not people can write nature paper one. It's a good story, let's publish it in Journal of Crustacean Biology. I said, no, let's try nature. I said, no, I said, publish in nature. I said, why? I said, two reasons. One is a cool story. Yeah, marine snow, it's called marine snow. The animals for them are called marine snow. I said, second reason why it's not interesting, because it's near Christmas. We found it out in our November. I said, why? You know, marine snow, Christmas. I wasn't joking. We sent it to nature. We accepted in 3 days. And it came out just before Christmas. Now, it is surprising what nature and science will take. Oh, this one actually got almost got into trouble. Because nature and science has one very bad habit. Hong Kong doesn't have this problem, but Taiwan does. Alright? So Ming Xiu, of course, was from Taiwan. When the paper came out in the proofs, you received the proofs, all of us were excited. Ming Xiu read, oh, I read the science, everything's perfect. I read, yeah, everything's okay. Then my student at the time, Gan Ti, came to court, hey, 老闆有事啊？有咩事啊？ I read, everything's okay. No, do you read the address or not? Nature changed the address from Taiwan to Taipei, China. Province of China. Without telling my Taiwanese friend, in Canning, he said, withdraw paper, withdraw paper. They don't withdraw. Just tell nature they cannot do this. Nature has a very bad habit. They like to keep China happy. That's a nice side story. This was a cool paper. You know, in Taiwan, when you get a paper in nature or science, I mean, how much money they get?
half million $1,000, I think, at least.
Yes, the researcher is rewarded by $500,000 Taiwan dollars. Do they get this kind of reward in Hong Kong? No. Yeah, you don't get it in Singapore. Yeah, when I found out in Taiwan they get this sort of things, of course my old friend gave me a lot of food. Then I asked my boss. My boss said, no, I give you something better. I said, what? Tap on the shoulder. Very stingy. Hong Kong same, right? Maybe lah. We don't get money. In China, how much would they get more money, right? I think for nature and science.
I think so.
Yeah. So many countries, especially Asian countries, have an incentive for big journals. Well, anyway, cut a long story short for this, so I tell you stories. We started putting papers together using basic biodiversity information, taxonomic data, to publish a whole series of good papers, some in nature, some in science, some in tree, also quite high impact. Tree is about 10 or 15. And we began to realize that actually, when you take the data and analyze it in a bigger way, getting it published in big journals is not a problem. This is a paper we did on Sri Lanka, right? To explain the diversity down there, because several of us did a lot of work in the islands down there. And when you integrate, when you mix biogeography, geology, different groups of animals together, you can actually write a fair number of fairly good papers in pretty good journals. What we did on limestone, the world's smallest fish. We took data we did on pig swarm fishes and put it into a conservation plan. When I said the other day that taxonomists and people doing basic data must get involved with big papers. This paper, for example, the first author is a modeler. He crunches data. I told my guys, make sure you get involved. Why? Because they are the ones who found the fish. They are the ones who name the fish. They are the ones who say what the fish are doing. When the modelers first took the data and wanted to write a big story, they didn't need the fish people, because the data is already published. But because I know them, I said, no, you cannot publish without them. So they came in, and the paper actually better, because you can actually explain more about the biology of the fishes. So I would say, when you do these big things, get involved. All right. After a few years, I proved to my heads and deans it can be done. Then I started regretting. You know, sometimes you want to do something to prove somebody wrong. And in the process, you do something stupid. After a few years, after showing it can be done, my bosses started getting a bit more annoying. Last time they said can't be done. Now they say, how come only 2 this year? How come only some of you, not the rest, you know? So the expectations, this Chinese society, from cannot be done, can be done. Oh, why so little? Then I had a second problem, which I must tell you, because if you follow this way, which I've done, you may regret. Some of my young scientists started playing the game. The reason why we hire young people to be scientists, to be lecturers, to be professors, is because they are supposed to be passionate about what they do. Good teachers, good researchers. Some of my young people, even middle-aged ones, started playing the game. They started choosing topics that would get them high-impact nature or science papers. I got one colleague, said, why are you doing this? You are a botanist. I said, no, but it's not high impact. I said, but you're a botanist, why are you playing with fish? No, this is high impact. I saw the data down there. I can crunch it all, I can publish it in science. I said, but you're not a fish person. No, it doesn't matter. High impact most important. More and more of them started getting upset because, you know, yao yan, right? And they felt that it's something they can do. From passion, it becomes mercenary. You do it because it's good for you, even though you're not an expert, even though you're not interested in it. We have professors telling their students, don't waste your time writing all these small papers, just concentrate on this one nature paper enough, right? Whether you're interested or not important. Get this paper out, you're famous. Now, then when I listen to this and I hear my colleagues talking like this, I start asking myself, what on earth have I done? I've corrupted all of them. From doing science because it's fun, to doing science because it rewards you even though you're not interested. That's why the next thing that comes is it really what you want? Now, over the last 10 years, as I've seen all this change, okay, I've seen my university change, I've seen my college change, and in a way, I actually half regret what I did back in 2003, right? When we were publishing papers because we were interested, it was fun. When people start publishing because it gets them high impact and better chance of promotion, thinking it's the most important thing, it feels wrong. It made me start asking questions like this. What is a university for? What is the university's job in training young people? To make you write science and nature all the time? To make your university famous? To make yourself famous? Or is our job, the professor's job, to train you to think? Now, that's a question I need you all to answer yourself, okay? My belief, the most important thing is not nature or science. The most important thing is, have you begun to think correctly like a scientist should think? Logically, calmly, objectively. Follow your heart, your passions, because that's how the science takes you to new heights. Nobel Prize winners, we looked at them, most of them succeed because they love their job. The heart decides what you take you to the next level. Many Nobel Prize winners don't have money in science and nature papers. Yet, we believe today, the more nature and science papers you have is what makes you a good scientist. I think there's something wrong. Okay. Grad students here, if you have a choice, please go and read these 2 lovely books. I don't know the authors, I don't make any money if you buy the books. Right? Declaration of conflict of interest first. Right? This book can be read in half a day, 1 day. It's about what knowledge acquisition is all about. Right? What a university should be doing. This is the book that will describe to you why the Americans had the atomic bomb. Even though they never planned for it. The people who brought the men who built the atomic bomb to America did not bring Einstein to America because he could build an atomic bomb. They invested in Einstein because he was one smart but strange physicist. 20 years after they invested in him, they realized this man held the key to the atomic bomb. And they were so lucky because if he had stayed in Germany, either he'd be dead or he'd be forced to build one for the Germans. The second book tells you about universities. Tells you about your university, because it tells me about my university, right? And it says that basically we have decided that all science and research is a commodity. We trade in commodities. We trade in impact factors. We trade in citations. And we are so obsessed with it, we may forget what actually we are supposed to be doing. KB will say, I like Henry Kissinger. Yes, I do. I read almost all his books. Okay? Among one of his books, about his career as a Secretary of State for the US, he wrote this, right? He was talking about Nixon at the time, his boss, President Nixon. You know, he had to resign, right? So he wrote about his times as, Secretary of State for Nixon. He was talking about Nixon, okay? We work very hard for the things we think is so important. And we are willing to work every day for it because we think it brings us glory. Only at the end, then you realize actually that's not what you want. But then by that time, it's probably too late. And you make mistakes. Nixon's mistake was not, well, he was not a nice man, right? But he believed that what he was doing was more important than anything else, including breaking the law. That was his tragedy. All the young scientists here, as you begin your career in the next 10, 20, 30 years, please remember this, right? Once you're too old, it's too late. Ask yourself, why do you join the university? Why do you become a graduate student? Why do you want to become a lecturer and a researcher in the first place? I ask myself this question very often these days, right? My university wants me to do a lot of things for them. Sometimes I ask myself, is it worth it? For you, as you look for a job, for the young people here looking for promotion and tenure, my advice, my suggestion, whatever you do, be curiosity driven. It's not whether this paper goes to Nature or Science that's important. It must be fun. It must be something that you're curious about and you want to find a solution. Why is this stupid animal doing this? That's a good question. Will this paper get me into Nature or Science? That's the second or third question, not the first question. Right? Never let that be the first question. If you're a teacher, teach well. One reason why I got very angry with the system that we created is some of my young professors became so obsessed with nature and science, they became lousy teachers. That means students are not important, I just focus on nature and science. That's bad, right? If you're too obsessed, you fail as a professor, which is to teach. That's the most important thing for a professor. We train them well. Young people, many of them behind here, we have to train them not only to think well, but to be good human beings. Yeah, I know that's not our official job. That's the parents' job. But you need to be good human beings to be a good scientist, right? As your director says, 識做人啊，有良心. Okay? Yeah, I know it's not something official, but do you know how scary it will be if you 冇良心? The bad things you will do. No, not good, right? Always ask the question, what decides good science is the good question, not the tools you have, not how much digital technology, how many machines you have. The question is what makes the science and the scientist. Publish. When do you publish? You publish when you have a story to tell, small or big. When you want to share with the world, you found something interesting, publish it. High impact, low impact, so-so impact. Why? Because this is your job, to share information with the world, right? Don't worry about making mistakes. I have a colleague, he published 5 papers in his entire life. Why? Because he told me, Peter, I do not publish papers other than they're perfect. His last paper, I took it, I said, you know, Dr. XXX, you know, this sentence, there's 2 full stops missing. Stormed out the room. Perfection is an illusion. All right? You make an honest mistake in the paper, it's fine. The only people who don't make mistakes in publications are those who don't publish. The more you publish, the more mistakes you make. But here's the good news. The more lessons you learn. Sorry is a very good word. Okay? I made a lot of mistakes in my life. Okay? I published a lot of papers, and I made some really stupid mistakes. But they were honest, stupid mistakes. So I don't regret it. And I learn from them, you move on. Don't beat yourself up over mistakes, because that's how science works. If you don't make mistakes, you're not making progress. Okay? You must be honest with yourself. And for all the scientists down here, scientists are a very annoying group of people, right? Most of them think when they're doing something, whatever research they're doing, they're the center of the universe, right? I think the deans and the heads here know, your fellow colleagues can be very annoying. You think what they're doing is the most important thing in the world. No. Everybody's work is important. So you have to be part of a community of scientists, right? You're not the center of the universe. So to end this talk, I tell all my young postgrads when I meet them, you need a broad scope of science. Science today is very complicated because so many things are happening, right? You cannot just focus on like bee crabs and nothing else. You need to see the bigger picture, right? You may be a jack of many trades, but at the end of the day, you have to be master of one. Okay? The expression is jack of all trades and master of none. No, a master of one. But you need to understand a lot of other things. I tell my young graduate students in my lab, okay, when you read the newspapers, read the economic section, read the politics section, not just the section about fashion or cartoons. Why? Because everything affects what you're doing. You need a bigger picture. Right? Keep this in mind. You will know when you are a major player. There's a word I use whenever we look at young staff for promotion and tenure. We ask this question of all our young faculties. Are you a player in the field that you're working on? What do you mean? When I have a young staff coming for promotion, I usually ask the people in the field, person X, do you know him? I ask a few of my colleagues in the field. If they all say, "Oh, thank God," you are in trouble. Very often I will hear, "Oh, this young man, very good." I say, "Yeah, why do you know him? He's not published in Nature Science." "No, I read all his other papers." Clear thought. Okay, last point. Okay? I always ask because I want to find out what the community thinks of this particular young man or young woman going up for promotion and tenure. Right? When we look at promotion and tenure, we don't just look at nature or science. I've got young people, right, who have lots of nature and science papers. And when we ask the community, "Do you know who this guy is?" "Don't know." "But it's got nature and science." Yeah. The community will know whether you are a player, whether you are young and up and coming, whether you are a major person in the field. The community always knows. The scientific community is a very stupid community because it's still very old-fashioned. It respects scholarship. The people who work in your field will know if you're a player, whether or not you've got more nature or science papers. If you've written a lot, interacted with them, played your roles, you will be accepted as a player. And that usually means you deserve your promotion and tenure. It is a bit old-fashioned, I know, right? I'm not saying don't publish in high impact. Choose. I'm saying publish widely. You don't just need nature or science, right? The community, if it accepts you, I believe most tenure and promotion committees will give you that chance. I think most professors are good people. Most of them. Okay, bye side. Thank you very much.
Thanks, Peter, for his excellent talk, and I think the floor is now open to Q&A. Any questions from the audience?
Thank you so much for the very fascinating story. I would like to ask about, sorry if I missed, did you start your story from when you became a faculty member? For what you have told us, the stories, do you tell us from the beginning in your faculty, being
Okay.
a faculty or being a graduate?
How did I end up in the faculty in the first place?
Oh, yeah.
Okay, all right. So I joined the faculty in 1990, right? Now, when I became a faculty member, okay, I replaced one of my old professors, who was an entomologist, right? Now, before that, I was doing all sorts of funny things like teaching in schools and everything else, right? So, in that sense, after I finished my university, I went out to teach, do all sorts of things, did my PhD part-time, because I had to work for a living. Then I got my PhD in between. Then the university had a job. So I applied for it. Now why did I get it? Very simple. Because even though before I joined university, I liked working on my fish and crabs. So I was publishing on them even though I was not in the university. When I went in for my interview for the job, one of the committee members said, "Why are you here? You're not a Cambridge scholar. You're not a Yale scholar, right? You were a teacher in high school. What makes you think you can come here?" Yeah, very blunt. Is it? Because I think I deserve it. Then you go, "Hey, you publish a lot of papers. How can you publish papers? You're not in the university, how can you publish papers?" Because I like it. Because it was fun to publish papers on crabs, even though I was a teacher. Okay? And then other committee members said, "Oh, he is interested." And of course, I was lucky because my head of department didn't hate me. The boss must like you, the boss hate you no matter how good you are, so no use. Right? So I got into university as a young professor, good life, because it was enjoyable. Right? And for the first 10 years of my life, I just basically did what I like to do. Chasing crabs, chasing fish, doing all sorts of stupid things. It was good fun. But then by the 2000s, my university started changing, get more obsessed with SCI, impact factors and all this. That's when I started, play the game I was telling you about. Previously, I never cared. But then the world of the 80s and 90s was more innocent than now. I think, Joe, Carl, in those days, Mogulina, right? World was more innocent, right? Yeah, So, that's life, right? These days, of course, it's probably a bit more difficult to get into university as a professor if you don't have a good track record, right? The track record is important. I'm not saying it's not important, right? But I think most interview panels, when they talk to you, they can detect whether you have the passion or not. When I interview young people for jobs right now, right? Do I look at their nature and science? Actually, no. Do you know how I assess people? Either I assess them for coming to university for a new job, or I look at them for tenure and promotion. You know what I look at? I look at all their publications, not just nature or science. What I look for, okay? You come in, what are you? You say, "I am an ornithologist, I'm a bird person." Fine, I look at all your bird papers. I don't look at all your other papers, because people nowadays, they publish so many things, right, with different colleagues. You're a bird person, I look at all your bird papers. I look at the bird papers, I see your role in each of them. Are you just farming? Very famous thing in Chinese society, farming everywhere, right? Or are you really actually involved in the work because your background says that? Then I ask you questions, you answer them. Then I say, "Oh, all these papers, you had a role. You are a good author in each of them." Okay, I count them. Same for a promotion. I've got people say, "Oh, I've got 50 papers, 100 papers, you should promote me." I say, no, I promote you on the basis of what you are supposed to be. If you say you're a birdman, I promote you because you are a great bird scholar. I don't promote you because you have 50 papers. Is that fair? I think so. They say not fair, but that's the problem. Okay, same, when I hire young faculties, I ask them the same questions, right? What I say here is that body of work that you do, that what you are, right? That will get you across the line when the time comes. Other questions?
Okay.
Thank you for asking.
Any more questions from the audience?
The students are the same as my students.
Yeah. I'm sure. Hold on. Well, with all those expeditions that you've done?
Ah.
How much time you spend in Singapore?
I used to do a lot more expedition when I was younger. So those days I would spend usually several weeks, several months out of Singapore, all over the place, right? Over the last 5-10 years, much less, because the university wants me to make money for them.
Okay. When you do the fundraising.
Yeah, also that. So,
museum and the-
yeah, I used to not be so fat. I mean, the problem is when as you get older and I assume more experience, they give you more responsibilities, right? So they make you do other things like administration, running departments, balancing budgets, fundraising, right? And so on, right? It's no fun, but it's important, right? So I do a lot less these days. Yeah. The secretary doesn't allow me to run away. How fierce is the secretary? Quite fierce as well.
Yeah.
Quite fierce.
Okay, any other questions? If not, then we have another big round of applause to Professor. Oh, one more. I think there should be some refreshment outside, so feel free to. I think there's some sandwich and refreshment. Just feel free to enjoy some.
Okay.